Oh, I heard somebody else just log in. Who just logged in? Okay, well, worst comes to worst, because this was unexpected. I got the phone call at about 6 o'clock last night that my daughter was having to self-quarantine by being exposed to somebody who tested positive at recess. And since I'm a single mom, I have to teach from home. I can't let my 8-year-old be home alone. She would never get anything accomplished. So I'm going to give them just a couple more minutes to log into the Google Meet. I am going to record us. Like I said, those of you that are remote, you're free to unmute yourself if you have questions, because it won't interfere, unless you're talking at the same time. It won't interfere with online at all. And I have children that are not doing what they're supposed to be doing at all. I can see their screens. I can see their screens online. You are welcome to go ahead and start the opener. I know it's super teeny tiny on my screen, but question 1, where are electrons located? Question 2, what charge do they have? Question 3, how would the charge that they have affect where they could be located? Do you think it's possible to know where an electron is at any given time, being what you know about electrons and atoms? This is the first truly difficult concept that I've tried to teach you, and I get to try to do it from my home. And I have lots of kids that are not doing what they're supposed to be doing. Okay, they're working on the opener right now, it looks like. Let me double check and make sure I didn't mess it up. I did that in Earth space. I do apologize if my daughter comes in and asks for help. She's new to remote. And I don't know how you guys teach little kids math anymore. I say you guys, teachers, it's different. It's not what it used to be. Okay, good, everything's hot. So far, it's only my remote babies that are here. That would be Tiffany and Toddy, because you've been in person. If you had, I got my sun on my face. If you have been taking your notes on paper, you need to, obviously, because you're quarantined, either take a picture of them and save them as a PDF, or you can use like Evernote scannable. You can scan them, or if you have a scanner at home, you can do that, because I'm obviously going to have to be taking notebooks digitally only this 6 weeks, because I will be out through next Friday. I am only giving them another minute, and then I'm going to start, and I will just put this on YouTube through my link on Canvas, just because I'm not going to be able to wait too terribly much longer. Let's see. Did anybody else? Aiden, Jeremiah, Mia, William, Robert, Valerie, Luke, Eva. Yes, sweetheart. I have a class I'm getting ready to teach. You need to make it quick. What up? What? Okay, well, do hula hoop for 30 minutes. Impress me. I'm so sorry. Like I said, I am doing the single mom thing from home, and it's going to be like that. I'm going to be distracted. I do apologize in advance. Y'all are not going to be able to do this assignment without help. This is different from anything that you have ever seen before. I'm just checking on them. Oh, this is going to be a fun week. Oh, did I hear somebody ding in? Maybe in the classroom. Alexis decline. Okay. If you're just now dinging on, there is an opener. It's talking about electrons around the nucleus. I am still patiently waiting for my in-person students to join us so that they can see what we're doing. Worst comes to worst, I will be putting this up onto, through my YouTube onto Canvas. I think I'll double check my daughter. Sweetheart, I'm trying to teach class. Don't play your music too loud. I got the door shut, but hey, is that following somebody? Oh, I see a chatty. You don't understand the last two questions. Okay, so number 3 basically says in English, the fact that an electron is negatively charged, does that control where they have to be? The fact that it's a negative charge is number 3 in English. Well, it is in English, but you know what I mean. Number 4, okay, do you think that we know for sure the exact pinpoint location of an electron all the time? Is what number 4 says. Okay, y'all. In person's not wanting to join us, so I am going to start. We will not get through this if I do not. You guys have notes 14. This is an intro to. Oh, I just heard another ding. Okay, no problem. Like I said, if you guys are remote, I don't know how bad it's going to reverb out onto in person, but you feel free to unmute yourself and ask me a question. I'm trying to listen. I wish that light would get off my eye. You're free to ask a question if you have it, especially if I don't hear my meet thing go boop. Okay, so got so many different things going on right now. So what we're doing is we're going to start doing quantum mechanics. And in my opinion, this is a little out of place. I would have preferred to have done ions first, but we have been told that we need to go into quant first. So we talked about Erwin Schrödinger. He should have the little dots over his eye, but I couldn't make it do that in Google Slides. But his model was called the quantum mechanical model. I tried to underline everything that's supposed to be filled into the blanks to make it easier for you. I am sort of adopting, not today's, but tomorrow's notes from old notes that I had. So it's going to look a little different. I'm going to try to tweak your notes 15, so they more match what I do, just because things are sort of flipped upside down. Y'all will see tomorrow what I'm talking about. But this quantum mechanical model says that specifically for a hydrogen atom, it describes both the energy and where you find an electron. It's specifically for hydrogen, the simplest of the atoms themselves. Basically what it does, and you don't have that second line, is it predicts the location of an electron. And the important word there is predicts, because we honestly don't know, because they're traveling so fast. We can't pinpoint them at all times. I need to go back to your notes and make sure that I didn't miss something. Check online. Yep, they're still not here online. I will post this to help them. And if I do go too fast, since all of you are remote, just come on and let me know. The way that they do notes at the school is to make this a little bit quicker for you. So, oh, I didn't animate this. Bohr's model was like the way that the planets go around the sun. They're on these perfect rings. And we actually still draw it that way because we draw on flat paper, and it's easier to do a two-dimensional model, which is just a circle, versus the three-dimensional model, which is Schrodinger's, which is a cloud. It's not a ring, but Schrodinger's model has calculated how likely, which is called probability, that it is to find an electron at a specific spot. We honestly cannot pinpoint them. Like I said, they're almost moving at the speed of light. We cannot pinpoint them, but we can guess the area that they're going to be in, and that is called a probability. Like I said, if I'm going too fast, please let me know because there's not too much on these. Okay, Heisenberg's uncertainty principle. What I just said, it's impossible to pinpoint an electron. It is impossible to know both where they are, which is their location, and how fast they're going and in which direction they're going, which is called velocity. So at a perfect circular ring, it becomes this almost ball. Like in the first cloud that we're going to talk about, the S cloud, if you think of like a blown up beach ball, that electron could be anywhere on the surface of that ball. We do call those electron clouds. And this particular principle is going to give us a 90% sure that that electron is in that spot. Like I said, they're literally moving at the speed of light, almost, not quite, almost the speed of light around the nucleus. I didn't have another one. I didn't animate this. I'm double checking online. Let's see it. Double checking their screens. And I see some people actually have the homework up. Please do not try to do this until I explain it to you. So inside the electron cloud, I don't know why these are not animating right. There are different, what we call energy levels. Now, when we did our, let me go grab it. When we did our colored, there we go. So when I had you guys do your colored periodic table, and I know it's difficult to be bouncing back before my pin slide and my personal slide, but when we color coded this, and I can't tell if I'm holding up at the right level, when we color coded this thing, there were these blocks up at the top. If you've got markers, specifically what I used was red, blue, purple, and green, we are going to outline our electron shells or our clouds, because this periodic table actually organizes them into their shell. That was one, and then this numbered thing, that thing that we've got up in the corner, and I know with what I'm going to put on YouTube, you're not going to be able to see that slide, but we have these sort of like a follow the yellow brick road, but I did it in red. We're going to be doing that tomorrow, and you're going to be putting these onto this periodic table. And for those of you that are remote, I let you use this thing all year long. It is a giant cheat sheet. Now, there are 4 parts for energy levels. Part 1, when we put this thing together, this periodic table that you guys cannot not see with my screen as far as this YouTube link, we put the numbers 1 through 7 down the left-hand side. These are energy levels, and it corresponds to the period, which is what goes left to right. In fact, if I change the way that, no, I don't want to change the way that this is presented because then they can see everything that I do. But on a, now I'm going to have to. On a periodic table, that's not going to work. I didn't think about this before I open this up. Let me open my periodic table. There we go. That's the one I'm looking for. I'm going to change the way that this is presented. If you bear with me just a second online. I'm so sorry. It is going to be bumpy because I am working from home and I'm used to being in person. Okay. So this number, I am about to be flipping back and forth like crazy, and I'm not trying to give you guys whiplash, but our periodic table, if I can figure out where I put it, here it is. Here's copper. Okay, if you count down, we put numbers on our periodic table. This is the first, the second, the third, the fourth, the fifth, the sixth, and the seventh period. Those were numbers that you should have put down the left-hand side. Now we find copper, and we go all the way to the left. It is in the 1, 2, 3, fourth row down. So copper is working on its fourth energy level. So I'm going to go back to my notes. Silver, and I've already put the answers on here. If I go back to my periodic table, let's move aside. All right, so silver is Ag. It's one of the strange ones. Oh, and by the way, look over set 2 for your element quiz tomorrow. I go all the way to the left. That is working in period 5. It's the fifth one down. 1, 2, 3, 4, 5. So these elements on this row are working on their fifth energy level, or they're the fifth period down, is where I'm getting that from. Radium, if I go back over to here and I find Ra, which is down here on the bottom, that is the, if I can get it to stop, there we go. It's 1, 2, 3, 4, 5, 6, 7. Radium is working on its seventh energy level. So this is all the way across. In fact, that is the last energy level, is the seventh energy shell. Oh, you know, it's going to do BSS. So when we put those numbers 1 through 7 down the left-hand side, that is the energy level that that element is working on. That is the one that it's in the process of filling. Part 2. Now, I wish I was there in person so I could at least attempt to draw on my board. And I've been frantic this morning trying to put pictures up here for you. In your notes, you guys have these, okay, at the very, very, very end. Okay, these are what are called Vesper. It's the shape that these orbitals look like. If I go back to my notes, your subshells, your energy levels, your sublevels. We have 4 main energy levels that we use to describe electrons. The S looks like a beach ball. It is a sphere. It's not a circle. It is a 3-dimensional ball. And so electrons could be anywhere dancing along the surface of that ball. The P shell, I always said, sort of looked like a dumbbell, or if you took 2 balloons and you tied them together in the middle. So you have to think of it 3-dimensionally, that they're coming out towards your face and they're also going into the screen, that they could be anywhere on here. The D, to me, almost looks like the flowers or the petals on a flower. They could be in any one of those 4 regions. And then F is just crazy fancy. It's X, Y, and Z axis. It's completely and totally 3-dimensional, crazy kind of stuff. I'm not going to ask you to draw these things. So energy level 1 is working on its first energy level or subshell. It's using that to fill electrons. We call this the S cloud. It's the one that looks like a ball. The second energy level has got 2 different ones that it's filling. And that could be the S or the P. I know this doesn't make sense until I show you the way that it's blocked out on the periodic table. But energy level 1 is only an S. That's the first row down. It's hydrogen and helium. It's just 2 elements on there. Energy level 2 is lithium, beryllium, and then boron across through neon. Energy level 3 is working on 3 subshells. It's got sodium, magnesium. We actually drop down a level from scandium through zinc and then back up argon. Like I said, this is not fun to be the first thing that I try to teach where I don't have my board and I can flip-flop back and forth. But the S is the first 2 groups on the periodic table going up and down. The P are on the right-hand side. They're 6 wide. The D, those are called the transition metals. You should have put an orange line through it. Energy level 4 has S, P, D, and F. F are those 2. If I go back over here, this is S. They're 2 wide. This is, let me make that smaller. Okay, this is P. Helium fits in that hole. This is P. This is D. And these are F. This was the one that we were color coding. Energy level 5. We don't actually use G and H. That's why they have little asterisks next to them. The only energy levels that actually have electrons in them are S, P, D, and F. And like I said, and I just showed you when I was flip-flopping back and forth between this and the periodic table, they're literally blocked out for you on your periodic table. And I used red, blue, purple, and green to block out my sections for my energy levels. So we don't worry about G, H, J. It's these 4 because we don't go past 118 electrons. So we really don't need those guys. Part 3, the number of orbitals in each subshell. You guys have that here, the orientation. Like it's on your canvas. It's this. I wasn't going to try to expect you to draw those. I'll come back and I'll talk about them as well as I can. But your S shell has only 1 orbital. It has 1 orientation. It looks like a ball. P sublevels have 3 orbitals, and they've got 3 orientations. So if I go back over, I'm so sorry, going back and forth. I will come back. Give me just a second. S is 1 way. P, you've got 1, 2, 3. D is different. D has 5. Okay. F has 7. F is a very, very fancy drawing. We're not going to be drawing those. Can't remember if I put more. No, I didn't. So, and these sublevels, these orbitals only hold 2 electrons each. So the S shell can only hold 2 electrons. The P shell, which has 3 of them, each one holding 2, can hold 6. The D shell, which has 5 orbitals, each one holding 2, can hold 10 electrons. Well, if I go back to my periodic table, first, second in the S, 1, 2, 3, 4, 5, 6 in the P. This is 10 wide. This is 14 wide. And I don't know how I'm going to do this from home. This thing literally reads like a book. Go back here. The D cloud has 5 orbitals. Like I said, each orbital holds 2 electrons. And then the F subshell or electron cloud has 7 orbitals and has 7 different ways that these electrons go. Each orbital has 2 electrons maximum in it. I don't think there was one more on here. There's not. Part 4. I just said this. Each orbital only holds 2. They must spin in opposite directions, 1 up and 1 down, or 1 clockwise and 1 counterclockwise. We're going to do that tomorrow. Oh, let me go back. So 2 electrons in each orbital, They go in opposite directions. Double check my online videos real quick. Yeah. Okay. All right, so you guys have a chart to fill out. Your S shell holds one orbital, can hold a maximum of 2 electrons. Could just be one, but it can't be more than 2. Your P shell has 3 orbitals. Each one can hold 2, so you could have anywhere up to 6. It could be 1, 2, 3, 4, 5, or 6. Your D level has 5 orbitals. Each one can hold 2, so anywhere from 1 up to 10. These are the maximum number of electrons on the right-hand side. Your F shell has 7, and like I said, if you take a look at the periodic table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Back to the right slide. Has a maximum of 14 electrons. I don't have my notes page in front of me. It's up here. Nope. Nope. This one. Okay, so that was this chart that we just filled in. After that, the right slide. So your first sublevel, your first energy level is this. Just these 2 atoms. This is called the 1s shell. It is the first row. We are working in the S cloud. Like I said, helium, if you move them over to that spot, it makes it a little bit easier. So 1s, 2 elements. The second energy level is this row. So not only do I have the 2 electrons for the S cloud, like I said, this is the S block. This is the P block. Not only does it have, and we're in the second row, not only does it have an S, but it also has P. So 2S and 2P, this holds 2, this holds 6. We have a total of 8 electrons if it's completely filled. Your third shell, which is this one. Now, when we put our numbers, it was 1, 2, 3, 4, 5, 6, 7. Then it was 3, 4, 5, 6 for these guys. So your third shell goes these 2, also includes these 10, and includes these 6. So we've got 2 in the S, we have 6 in the P, and we have 10 in the D for a total of 18 electrons that can be held in the third energy level. We're going to go more into this tomorrow. And then your fourth shell, 1, 2, 3, 4, we've got, and it was 3, 4, 5, 6, and then it was 4 and 5. So we would do 1, 2, 3, 4. This one, we've got this one, we've got this one, and we've got this one. This is not going to be fun to do remote. So we've got 2 electrons here, 6 electrons here, 10 electrons here, 14 electrons with the 4F for a total of 32 electrons that actually can be pushed into that 4th energy level. And once again, this is going here. So this is orbital notation. This is actually what we're going to start up with tomorrow. We are going to block out, like I said, that this guy sort of fills in this hole. These are your S's. They only hold 2. They are 2 wide. These are your P's. They're 6 wide, so it can hold 6. Your transition metals are your D's. They're 10 wide, so they can hold 10. And then your F cloud, these 2 guys down here, it's 14 wide. So you've got 1s, there's 2 of them, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Then you have to go back up. No, hold on, 4S2, 3D10, 4B6. You should have, if you have not done this on your own personal periodic table, which is this guy right here, which I can't tell if you guys are seeing my screen or not. Okay, you should have put the numbers 1 through 7 down here, which are the same as over here. And then we had 3, 4, 5, 6, and then we had 4 and 5 down here. That will help you quite a bit with what we are going to do tomorrow. And Norton's telling me I need virus stuff. So I'm going to go back here. Okay, if you did not do the quiz, that is what you guys should do. Yes, I know this is different. This is very, very, very different. I really wish that I was still in the room and not trying to do this from my computer, because this will be a hard thing to do from home. Once again, if you are remote, and I'm going to stop presenting. Okay, if you are remote and you had your notes done on paper, you need to switch them over to digital. I'm still taking those next week. We are going to do orbital notation tomorrow. I know we have to do light, and 6 weeks exams are next week. I will be taking your notebooks for a grade. If you were not here yesterday, you missed a test. Let me get my paper copy. The right class. If you are online, Veronica, Lucas, Matthew, Haley, Valerie, Slate, you missed the test. Okay, it's in there. I believe I
did it earlier today.
Did you do it earlier today? Okay.
Yeah, I'm sorry. My Wi-Fi was messed up yesterday.
No, it's okay. And it's, like I said, I just found out about this at 6 o'clock last night. So, yeah, I'll get into it and take care of it.
Okay.
Brayden, if you're online, you're not, but no, I'll actually go back and double if my computer will work. Let me stop.